Okay, so I'm Nancy Klehm, and I'm here right next to the LA River, February 4th, 2016. Next question.
Next question is talk a little bit about what you've been working on for the last couple weeks.
So I've been called into this project by Lauren Bond, and what I'm doing is I'm going to the area of the moon where there's these gigantic 60-foot circles cut out, and there are like study spaces. And as those circles got created, the asphalt came up, then the kind of the layer that actually helps set that asphalt came up, and then there's some soil that hasn't been exposed for maybe 50 or so years, and so there's a seed bank in that soil. It's very compacted, and there's what was done earlier by Jaime was to do some composite soil tests. So I've seen the soil tests. They're done at a narrow depth and a deeper depth, and what I came in to do is identify the spontaneous vegetation that's either blown in, gotten deposited by birds, or has finally seen the light of a day, so has germinated in these circles, and index those circles with the spontaneous vegetation, and then went back and we tested those circles for the tissue, the plant tissue. I'm generally interested in bioremediation, and I'm interested in the plant-soil interface as much as the fungal soil interface, the water-soil interface, and I think these are all things that are really interesting. And so if we can look at what these plants are doing with the soil that's there, we can start creating a database that doesn't exist because no one is interested in these plants, these native plants, and a lot of our spontaneous vegetation known as weeds, which I don't say because it's very specious of me to say. But there's no economic drivers to really study these plants. So if we can do a lot of baseline information gathering on this site, it's information for anybody that Lauren wants to share it with, and so it's really important baseline work. So we're looking at what these plants can uptake from the soil, and because it's a generalized area of 60 square feet, each one of these circles, soil can be very different from place to place, but what we're looking at is we're not taking the plant sample and the soil sample from the same place, we're taking from different places. But we're doing these kind of this is a general study area, and it's a controlled study area. So how much, if there is lead in this circle, how much is this plant taking up, even if it's not exactly a hot spot of this particular circle. So, because that's what we're interested in, how does metabolic energy carry and transfer these materials from one metabolic being to the next, metabolic of the soil, metabolic to the plant, metabolic of the water. So that's what we're gathering, and it's going to result in a bioremediation plan. And I'm interested in how there's going to be a lot of clean soil available to us. I'm interested in these other materials, these mulch materials, very, very clean manure materials, which is a nitrogen source, and how we can work with these local materials, and how we can, if we wanted to, kind of inoculate some of these circles with a more indigenous or localized microbiology from these healthier landscapes into these kind of strange industrial study pits. So I'm interested in the possibility of that, but I'm also interested in how these pits could perhaps recover that microbiology on their own and how they support plants through what they are now metabolizing with exposure to sun and rain and various things that blow in. So yeah, so I'm interested in the feral qualities of that, and also how we can bring some things back. And I think the biggest question about what we're working on is, can we bring back the fingerprint of this land that's been covered, can we bring it back from the most low-level garden techniques, which kind of a hands-off kind of garden techniques, allowing it to go fallow, maybe introducing some healthier soil, covering it with some healthy mulch from a beautiful oak woodland. Can we do that? And does it? And what does that grow? What kind of climax forest can that evolve into? So I'm really interested in kind of the longer-term vision of this project. The idea that you can plant something and then walk away and you've left a legacy, particularly if you're working with trees and particularly if you're working with a forest, which is one of the most complicated ecologies there is. It's a forest ecology, land-based ecologies, I should say. So my vision is that we start working with some native trees and shrubs and a simple ground cover layer, like maybe 3 layers, to see what it builds over time. Who comes to it, who deposits their bodies, their poop, their frass. If they're insects, it's frass. But what happens there, and I think that's something that we're going to be working towards.
I stopped it. Perfect.